Hi, I'm Conor Horan-Kates. I work at Salesforce.com. I'm a senior member of the technical staff in quality engineering, as they just said. I'm here to talk about Vagrant and Rouster and how we're doing functional testing at Salesforce.com. So let's start with who am I? This is pretty quick. I haven't been in the industry for too long. I've worked at a company called Webroot software. We did some anti-malware solution. I was a tester in quality assurance then. Started on the front end and started moving towards the back end where the updates, where our clients would update, check in for subscription status. Around that time, I got interested in automation, and Salesforce got interested in me. So then I started working at Salesforce. I started as a quality engineer in the data center automation group, or one of the data center automation groups. And as part of joining that group, I've moved towards a developer, and with the help of some great guys on my team, even into some systems engineering. I don't consider myself a systems engineer, but I have some of those qualities. Most of the code that I write, or used to write anyway, was in Perl. Boo, hiss, any? Okay, yes, there we go. And now everything I write is in Ruby. It took a little while to, yes, there's the clap. It took a little while to get over the similarities of Perl and Ruby and stop writing Perl in Ruby. But now that I've gotten over that, the object system and exception handling in Ruby, I'm never going back. So that's who I am. But what are we here to talk about? We're here to talk about Rouster. So Rouster is there to solve a problem in the testing world. So the problem is catalog compilation and application are totally separate beasts. So while RSpec is awesome, don't get me wrong, it's great. I don't like writing it, but I like using it. It checks that your catalogs compile successfully, but just because that happened doesn't mean that the systems that are getting that catalog will actually be able to use it. So RSpec is definitely the fast way. Rouster, in my mind, is the secure and kind of trusted way. What it is, let's do a little audience participation. Everybody know what Vagrant is? Hands? Okay, good. That's exactly what I want to see. We don't have to talk about it at all. Vagrant is an abstraction layer for virtual machines. Rouster is an abstraction layer on top of Vagrant and gives you some pretty cool testing methods and convenience functions so that you can write Ruby code that controls your Vagrant virtual machines. Does anyone get the joke, Vagrant, Rouster? Does that translate? OK. I thought it was really funny. I spent a long time thinking about the name. So here's a Rouster. It's a cop, right? So your Vagrants are great, but if you're just SSHing into them and running commands manually, that's only half the battle. With Rouster, a basic instantiation, you just require a Rouster. In the simplest form, all you need to do to create a worker to control a Vagrant virtual machine is tell us what name it is. This requires that the Vagrant file be in the same directory as your Rouster script or in some directory above that. There's some more advanced instantiation options, but let's keep it basic for now. Just tell me the name of your virtual machine, and now you can start using it. So all Rouster workers support the traditional Vagrant faces that you expect, up, suspend, destroy, status, but Rouster adds the additional layers of run, so you can run any command that you want inside a virtual machine. You can pull the exit code, standard out and standard error, and do what you will with those. It also gives you the ability to put files inside your virtual machines and then pull them back out. So really quickly, we just cat etc host, we can upload a file, and then we can get that file back, tear the machine down. So we'll talk more about some more advanced uses of Vagrant, Rouster. But let's start at the beginning. And the beginning is where did we start at Salesforce.com? So at Salesforce, the team started off with 6 engineers. And actually, it really was a DevOps team. 3 systems engineers. 2 of them have had Puppet experience in the past, 1 without. 2 quality engineers, and then 1 developer from the R&D side of house. So we were really split right down the middle. As a whole, we had very little Ruby experience. Okay, we had no Ruby experience. We're Perl on the dev side and Shell on the ops side. So I think the devs had a little bit of an easier job coming to Ruby, but it wasn't easy. To help us through that, we had some education. So the education that we used was Pro Puppet. It's a great book by Puppet Labs, well, in conjunction with Puppet Labs. The Puppet 2.7 cookbook. I know we're in Puppet 3 world now, but a lot of the patterns that you read about in Puppet 2.7 still apply, and this is actually my favorite book about Puppet still. We also got some help from Puppet types and providers, because once you get past simple manifests, you're writing your types and providers too. And the documentation, well, isn't that great. I think Puppet Labs will even say the documentation is read Puppet types and providers. So we did. In addition to that, we also took the Puppet Introduction and Puppet Developer classes from Puppet Labs. They're awesome. We're putting, so everyone on our team went through both classes. The rest of Salesforce.com that wants to use Puppet will be going through the Puppet Introduction classes. Really what we're trying to do, our team right now is the gatekeeper for putting Puppet code into production, and we can't do that forever. So by teaching other people how to write Puppet and how to use, how to test it, we can get out of that business and people can start shipping their own code. So we talked about composition, education. What do we do with tools? Our first attempt at testing tools was RSpec and RSpec Puppet, and that happened because we jumped on Google and said, how do we test Puppet? And RSpec Puppet came back. So we're like, that's what we're doing. Nobody really knew what it was. Nobody knew how to use it, but that's what we were doing. We also fell into Puppet Lint a little bit that way. The developers, we know there are best practices. I mean, even the systems engineers would know there are best practices in code. But Puppet Lint lets us apply them in a programmatic way. I like about half of the checks that Puppet Lint does, and the other half I can't stand at all. But they're community standards, and so either I need to convince the community that these are bad, or I need to convince myself that they're good. So I'm working on the convince myself that they're good. So where do we go from here? Well, where have we been? It's not where we are now, but one of the first things we had to do is convince management that we wanted to get out of Perforce and into Git. We wrote a little tooling around that, and it was kind of before Perforce was really talking about their Perforce Git kind of bridge. So that would have made it a lot easier to sell originally, but even this worked out. We were using, instead of asking developers and engineers to run the tests themselves, now we were running them through local Git commit hooks. So still running just Puppet Lint. The RSpec and RSpec Puppet use had gotten a little bit better. I think at this time, maybe half of us knew how to actually use it, and the other half were still copy and pasting. But local Git commit hooks still are not exactly ideal. Chmod -x in .git, I do it all the time, so they're not the best. At this time, we also found Vagrant. Our Vagrant file originally started off at about 39 lines, so pretty small, maybe standard. We named it the project PAB, or Puppet in a Box. So based on that, if you get the joke, you can probably figure out when we started working on this project. It was a while ago. With those 39 lines of code, we were able to support base images for every server that we have in the Salesforce.com application stack. 39 lines versus millions of dollars for an environment it's an insane return on investment. So once we saw Vagrant and how useful it could be, we were never going anywhere else. Where are we now? Strangely enough, we weren't even using Jenkins, really, back a couple months ago. Now we're using it, but our installation's still pretty small. I think it's awesome that it's small. We don't need a huge farm of Jenkins machines to run these tests because they can all run inside Vagrant. So we can have 4 or 5 machines for every one of our physical machines. We're still using RSpec and RSpec Puppet. We are now all able to write RSpec. No one's copy and pasting anymore. Looking for nods. OK, good. We're also using test unit. It looks like I couldn't figure out how to make RSpec understand one of the tests that I was trying to write, so we had to use test unit instead. I don't recommend splitting. I think it's a good idea to choose one and kind of go with it. So hopefully we'll be able to refactor that. We're also using test more, which is a Perl library. I know, we're back in Perl land. We're really using it for unit and functional tests of the ENC. There's no reason that it has to be in Perl or using test more. I think it was kind of, again, we're moving from all Perl to a mostly Ruby shop, well, at least on our side of the house, and Perl seemed like what someone wanted to reach for first. So that will be refactored, but right now it's in Perl. We also built a mock rack ADM, so for interacting with an ILO on a Dell server. We didn't want to have to be talking to live servers every time, or live DRACs every time we wanted to make tests to or test our type and provider. So the way that we did that was built a binary that mocked out the behavior of rack ADM, and now instead of talking to a real DRAC, we just talk to rack ADM. Our Vagrant file has ballooned to 237 lines, but now it supports base images for almost every host in production. Not just the application stack, the operational stack as well. So I was at a talk, actually just two talks ago, where someone showed a 180-line Vagrant file and was like, you shouldn't do this. And I got kind of embarrassed because ours is even bigger than that. What it turns out is that we're solving a lot of problems in our Vagrant file that are now Vagrant plugins. So we're doing things like IP address assignment, well, mostly IP address assignment. And there's all sorts of great modules for Vagrant that'll let us do that outside of our Vagrant file. I don't know that I think we should go that direction. The previous speaker's case was not everyone wants to write Ruby all the time. I want to write Ruby all the time, so I kind of think this is OK. But you know, the best tool for the job, and right now, Ruby gets it done. So where are we now? Part 2. We added an additional layer called Salesforce PM. So it's a Perl library. It's an abstraction layer to Vagrant machines. It's effectively the precursor to Rouster. Some of the problems with it, or the reasons why we wanted to move on into Rouster instead of just Salesforce PM, were 1, it's in Perl, and we're going to Ruby. 2, it was shelling out to all of the Vagrant faces, and that gets a little slow, gets a little old. You have to cd into the directory where the Vagrant file is. But the worst one was that it was creating a new sudo tty connection for every command that you're running inside the machine. When we get into some of the tests, I think it's in 2 slides, some of those tests need to run multiple commands, and instantiating a new SSH connection every single time is just, don't do it. But we did, so we had to move on. Some of the other downsides, it relied on an external project to power some of the more interesting functionality or interesting functions. It allowed you to inspect groups on the system, packages and services, as well as the users that lived on that system. Salesforce PM supported a subset of the is tests that we'll look at just a moment. But the real problem was Perl and test more specifically don't have a great answer for test isolation. There's no setup or teardown methods to speak of. So large portions of the code in each of our role tests is duplicated, and don't do that either. That's where we are now. Where are we going? I was hoping that I could remove this first part of the slide before I gave the talk today. Salesforce.com, we're not actually using Rouster right now, or we are in local machines, but it's not integrated into our CI system yet. We need to port the existing Salesforce PM tests over into using Rouster, and we also need to resolve some of the issues and to-dos that are in the Rouster code base. I don't mean to say that Rouster is not functional or that you shouldn't use it today, because I use it every day, and I think it's awesome, but it's definitely not a 1.0 product yet. It's still in the baking phase. One of the other big changes about where we're going is we're moving from all Vagrant VMs to an environment that includes physical hardware. We're doing this for two reasons. For real validation, whatever that means. Effectively, what that means to me is that Vagrant is great, but it's not an R610. It's not the machine that you're actually running in production. So there might be things that are different about the R610 that you don't know about until you're actually running on it. We also don't want to go just from Vagrant on our desktops to Salesforce.com customers in the cloud. That's a little dangerous. So real validation, the finger quotes are only partially snarky. The real reason, or the reason that I'm in most support of moving to a physical hardware environment, is there are devices in the stack that we just can't emulate in Vagrant. I'm talking about load balancers that are not server-based. Well, I'm mostly talking about load balancers. But things like storage could also be included in there. Vagrant is great, but it's not a complete solution. So moving to a real hardware environment is something that we're doing. So back into Rouster, we're at PuppetConf. Let's talk about how you can use Rouster to test Puppet. Just like before, you require Rouster, and to get access to the Puppet methods, just require Rouster/Puppet. And for any of you who write Ruby for a living, this is not the ppm methods minus object.methods.sort. That's not exactly what the output looks like, but it's what we need to talk about right now. So the main functions that we care about are get catalog, parse catalog, and run Puppet. The other three are kind of helper or convenience methods that may matter to your environment or may not. Get Puppet errors and Puppet notices basically just parses standard out and standard error that's been returned from a previous Puppet run. But get catalog and parse catalog lets you actually talk to the Puppet master, get the catalog based on a host name and some facts, and then you can examine that catalog with parse catalog. Basically what it's letting us do is, instead of copy and pasting resources from your Puppet code into your RSpec or into Rouster, we can actually determine what sort of tests to run on your catalog based on the catalog itself. It's a little meta, but I think it's where we're going. Run Puppet. It's the last one on the list, but it's actually the most important one. We run Puppet with sbin service puppet1-t to get the extra output, so that's what run Puppet does. I know that's not how everybody runs it, and maybe it's not even the best way to run it. So if anyone has better ideas or different ideas, I'm very interested to know what they are so we can get better. Here's my favorite slide, testing methods. This is what it's all about. So like before, require Rouster, require testing, and now you get all these great is methods. So you can check to see if the string that you pass is a directory inside a virtual machine. You can see if it's a file. You can ask if something is a group or is a user. You can find out if a user is in a group. There's support for testing the port status, whether it's active, and for our uses, active is either connected or listening. Otherwise, the port is considered open. Another one that's really useful is service and is service running. So we'll do a demo now to talk about what that actually looks like. I hope this works correctly. Hey, it worked. So let's look at the demo. So I have two demos. I have videos. Don't worry. If it all blows up, I'll just switch over to VLC. So here, just like you saw in the slides, we require Rouster. We require Rouster tests. We specify the name of our app host, or the name of the VM. We add a little verbosity here so that it's more clear what's really going on in the output. Basically, what the demo does is it installs HTTPD, does a little truffle shuffle in turning it on and turning it off, switching the port that it's listening to, and the tests are to see that Rouster can see that those changes were applied. So let's do that. Examples, demo, RB. So there's supposed to be some text that shows up right away, so of course it doesn't. But what we're doing right now is checking to see what packages are installed on the system. That takes a second. Effectively what we're doing is running RPM QA, parsing the output of that, and then taking a look to see the package name and its version. And that's returned in a hash, which you can then do things with. There's some limited support for other operating systems. We'll get into that a little bit later. OK, so it just installed HTTPD. You can see that the delta of before and after packages, when you install HTTPD, Yum does the right thing and pulls in a whole bunch of dependencies. So we took a snapshot before and then after. These are where it was installed. We can see that some crucial directories, or directories and files were created. var_dub exists, and that's default specified in HTTPconf. HTTPconf exists, and we can see its mode, who owns it. I kind of like this little hash, or this little array here inside the hash. What it tells you is user group other, whether they have this privilege on that file. So you can see a lot more about who can do what to the file without having to parse the numerical representation yourself. We do it for you. We can see that when HTTPD is running without any modifications, it's running on port 80. Before we installed HTTPD, we checked to see what ports were open, and after the fact, we can now see that 80 is the only port that changed. We can see that the Apache user and group were created. This is going to blow up, I'm sorry. OK. So we can see that the user and group were created. Then we can see that HTTPD is a service. We can see that the service is running. The is process running for HTTPD is probably not that interesting. All it really does is PSAUX and then grep against that output to find whether your process is running. So there's some work we can do there to make it really rock solid. Then what we do, you can see that is service running is now false. It's because in the code we shut down HTTPD. We did that so that we could get the HTTPconf, do a little awkness on it, and then send it back in and restart HTTPD. So when HTTPD is stopped, port 80 is active, is false. It's missing a question mark there. So now we can see that service HTTPD has been restarted. And after we modified httpd.conf and changed the listen directive, now we're listening on 1, 2, 3, 4, and we're not listening on 80. So no test there, but I think that's a pretty good example of all of the things that you can do with Rouster. But there's no Puppet there, there's no test there. I'm a QE, and we're at PuppetConf, so let's do something a little bit better. That's not what I wanted. So rather than just look at the code, let's step through the debugger. Why are you doing this to me? OK, Puppet and test roles. And we want 12, 21, 58, 81, 113. And we don't want to stop on exceptions. So let's get rolling. All right, so what you can see here, sorry, the connection's a little slow. This is a machine back at the office. So you can see here that when we instantiate, or when I'm instantiating this Rouster object, our Vagrant file actually lives in another directory from where the test is running. So what you have to do is tell Rouster where the Vagrant file is. Just give it a relative or a complete path, and then you're done. Just keep going. So we instantiate a PPM, which Puppet Master, and an app server, since we want to be able to run Puppet. Then the next thing we're going to do is we're actually going to run Puppet. So we need the Puppet Master to run Puppet first, so that it is managed before, well, So the disk manage pulls down all of its dependencies, and then the agents can check in, and everything will be happy. The array here is to specify that we will allow for an exit code of either 0 or 2 without raising an exception. That's mostly a convenience method so that you can leave one Puppet master up instead of having to constantly be restarting it. You only really need to restart your agent nodes. Restarting your Puppet master, don't need to do it, especially when a Puppet master Puppet run takes so long. So this allows you to do that. And then the last thing we do before we start looking for specific packages and files is make sure that the finished catalog run was actually in the output. So let's continue on until after the Puppet run. I should have done that just before I started talking. But it should be pretty quick. So you can see here that the line 25 and line 26, we are defining what packages we want to be installed on the system. Obviously, we want Puppet and we want Factor. Tried to mimic the Puppet DSL as much as possible so that it wouldn't be difficult for people to pick up Rouster and just start using it. So we have an ensure parameter, just like Puppet resources do. We're flexible enough to support true, present, a few other variations on that. But it's meant to look like Puppet. So if you're thinking it looks like Puppet, good, that was the plan. So you can see the expected packages here. You can see the expected files. You can specify an array of things that it needs to contain. These will be interpreted as regular expressions. Group mode owner, again, just like writing Puppet code. And let's see, expected groups. OK, I think that's all I wanted to talk about there. But now what you can see on line 58 is we have the expected files. And now what we do is pass them into a method called validate file. We pass the file name and then the list of expectations. And Rouster goes and runs all these commands to make sure that these things are true or false and returns the value. It abstracts all of that work away from you. You tell us what you want or what you're expecting, and we'll tell you whether or not it's true. So we can do that for files, groups, users, services, and ports. OK, so that was awesome. Nothing happened right there. That means all the tests passed. I don't know how familiar you are with test unit output, but nothing is actually a good sign. At the end of the run, you'll see a dot for every test that's passed, but assertions don't show anything. You can make it show things with some verbosity flags, but it's a good thing that nothing happened there. So now what we're doing is we're going to do the exact same thing on the app host that we did on the Puppet master, except that there are different packages that we expect to have on our app hosts. So you can see expected packages versus app expected packages. I really like the .merge method that Ruby has there, and it sort of felt like it fit perfectly here. So we're doing the exact same thing on the app host that we did with the Puppet master, except with some more tests. We're looking for more packages, more files, more users. Yes, so I just want to make sure that this gets all the way to the end. We can take a quick look at the code, and then we'll get back to my slide. I was planning for this demo to blow up in my face, and maybe that's the answer. Plan for it to blow up in your face, and then it'll work just fine. He says expectantly. OK, so the test ran successfully. When you look at the test in code, well, it looks exactly like it does in the debugger, except, well, it's prettier. So this is what I call manually specified testing. When we get to the get catalog and parse catalog methods, that's what I think is really automated testing. And so to talk a little bit more about parse catalog, what it's going to do is return a hash that contains a list of resources specified either as directories, files, groups, packages, users, services, the things that we know how to validate. I think a great place that Rouster can improve is talk about some of the other resources that can be included in a Puppet catalog. These are, in my mind, the big ones and the important ones, but they're by no means the only ones. OK, so that demo went as well as I could have expected. Now let's see if I can start the slideshow. Awesome. All right, so next thing I want to talk about is where's Rouster going? You've seen where it is, where we're using it. Salesforce.com, we're going all Red Hat Enterprise Linux. So most of the time that myself and my team get to work on this will be in support of that operating system. So yeah, Red Hat. Object model. So one of the things that I love so much about Ruby is its object model. Unfortunately, I'm not actually taking advantage of it for Vagrant or Puppet. We started using the object model in Vagrant around Vagrant 105. As soon as Hashimoto added virtual providers or other providers, the object model kind of blew up. So in order to get ready for PuppetConf, we went back to shelling out. It's not great, but it still works. There is a minor performance hit, but since we are keeping a persistent SSH connection, it's not as bad as it was in Salesforce PM. We'd also like to include the Puppet object model so that we don't have to stand up a Puppet master just to make queries to Puppet itself. We should be able to call faces without actually standing up a machine. There's no reason that the Puppet master has to actually be running. As long as we can instantiate an object that represents that, why wouldn't we do that? Save us a little bit of RAM. A couple other things that we need to do with Rouster is we need to get the pass-through implementation done. What Rouster does is it SSHs into machines to run these tests. Why does it have to just be a Vagrant machine? It could be any machine that you can talk to over SSH. OK, ignoring the authorization or authentication bit of it, which you can do with keys, or there are a couple other ways you could do it. If you ignore that, there's really no difference between a machine under your desk, a machine in the data center, or a Vagrant machine. So when we finish the pass-through implementation, you'll be able to run these tests, Rouster tests, in or on real hardware. Like all open source projects, we need better and more documentation and tests. That's not to say that the documentation or tests are not there. They're just not exhaustive. They're what I thought was needed and what my team needed to get spun up on how to use this, but we need to do better. I'm also very interested in what the community needs. That's code for I'm running out of ideas. So if you've got anything that we're missing that we should be working on, let's talk. So want to help. Here's some ways that you can help besides, well, a new pull request. That's basically the way that you help. But we also need help with testing. Do our tests work in your environment? The answer is no, they probably don't. They're not super specific to our environments, aside from maybe the names of the VMs. But I don't work for your company, so I can't tell that they work in your environment. Salesforce.com, we're using Vagrant completely with VirtualBox. We're not using any VMware. We're not using AWS. How does Rouster work with that? I don't think there are any problems, since it's just an SSH connection. But I don't know. Help me find out. Extending the support for other system configuration tools, like Chef or Ansible or whatever comes next. We're at PuppetConf, so we got to talk about Puppet. But there's nothing really Puppet-specific about Rouster, aside from the library that we looked at that supports those 5 methods. So if you want support for some other system, help me write it. Same thing with the operating systems. There is some limited support right now for Red Hat, Solaris, Ubuntu, and a little bit of OS X. But as I mentioned, we're going all Red Hat, so we're getting less and less time to work on those. So supporting those other operating systems would be great. And those regular expressions that we're using to parse stuff could definitely use some help. There's at least 30 to-dos in the code base. None of them are super advanced. None of them are refactors. They're kind of, what does it look like on your system? What other information would you want here? So to-do hunting is another great way you can help. The new test and convenience method said, again, that's code for I'm running out of ideas, so whatever you guys are interested in, send it away. And most importantly, I don't know why this is last, but we need an awesome logo. Vagrant has had 3 awesome logos, and we don't even have one. We need to do better than that, and we're going to do better than that. So I've got about 5 minutes left. That's everything that I wanted to talk about specifically. I really have some questions for you. I know it's not really fair. You're supposed to ask me questions, but I'm asking you. So one of the things that I mentioned is test isolation. The way that we're doing that is by duplicating huge amounts of code in individual tests and setting our Jenkins executors to 1. That's not the way to do it, but it is a quick solution and it works. I'm interested in hearing from anyone after the talk or now how you're doing test isolation. Another big pain point for us is credential management. What I mean by that is, where do you store the passwords for all the things? How do you do that in a secure way? Security doesn't want you committing that to source control. Well, you shouldn't want to commit it to source control either. But what if you don't have any other option? Are you committing it to source control? How are you handling that? The non-server Puppet agent testing, I think, is also something that I'm really interested in. As long as you can SSH into it, Rouster can probably work on it. We're not running any really exotic commands, but we're not really testing that many non-server Puppet agents right now, so I don't know how to do it. And negative testing, I think with Rouster, what it really does is it tells you that these files are there, or this user is there. It doesn't tell you that this user is not there. So when you're talking about trying to do like ensure false or ensure absent in your Puppet code, testing for that with Rouster is a little bit difficult, because effectively what you're doing is you're asking if this is a user and expecting false instead of true, which is a little confusing. So I'm looking for help on that. Wrong order. The ways that you can get in touch with me to help me answer any of those questions or to contribute to Rouster. GitHub.com/my name without the hyphen, thanks mom and dad, /Rouster. It's going to be given to Salesforce.com. We're just working through the licensing and figuring out how that's going to work. But feel free to file issues. My contact information is available there. On Twitter, again, no hyphen, just my name. And I'd love to talk more about Rouster. They said I had 40 minutes to talk about this, and I said I could talk for 40 hours. So I kind of tried to squeeze as much as I could in, but there's a lot more to talk about. Yeah, so that's all I've got. We've got 2 minutes for questions. Any questions I can answer? Anything I'm doing wrong? Yes, sir.
I was wondering how you were connecting your roles up from the master to the
Yes, so the question was, how are we connecting the roles that we're testing up to the Puppet master? The way that we're doing that is in our huge Vagrant file. Effectively, we have an external YAML file that defines what all the IP addresses for the different types of VMs we have are. When the Vagrant file, when you Vagrant up a machine, we have a shell provisioner that adds etc host entries for all of those hosts, so then you can find each other no matter where you are. That's one of those things that Vagrant has a great plugin for, that we don't need to be doing this crazy IP calculation and making sure there aren't any collisions. But it's a relatively recent plugin, and so that's how we're doing it now. I think maybe going the plugin route might be the right way to do it. Anybody else? Yes, sir?
Why do you choose running your scripts with the IRB and not via break file?
I knew that was going to come up. OK, so really, it's because I come from Perl, and IRB and Perl-D are very, very similar, and that's what I'm used to. I saw Patrick yesterday using require debugger and then debugger just in some Puppet, or it's in some Ruby code. I'm almost sold just on the 2-second demo that I saw with him, but the reason is it's what's familiar. So yeah, I wish I'd known about the real debugger before. Anyone else? Any other questions? Yes, sir.
Yeah, I'm interested in hearing a little bit more about your Vagrant file, actually.
Cool.
So say you have like 5 different types of nodes that you want to test with 5 host names. Do you have like one node definition that can handle all
So I guess that kind of depends what you mean by node definition. So we have, let's see here. No. Yes. We have a huge number of hosts that, nodes that are configured. So I think the answer that you're really looking for, I don't know how many that is what, 15, 20? We would want to stand up one per role. We're trying to have isolation as much as possible. But right now, all that Puppet really does is get the node ready for whatever application is going to run on it. It doesn't actually install that application. So right now, any machine is really pretty much the same as others. We have a mix of 2 different versions of Red Hat, and so that's really the only difference between these machines. As far as Vagrant is concerned, the roles that Puppet applies to it, they are very, very different. But from the beginning, they're all pretty much the same. I think another thing that I'd really like to use, I think I'm out of time. Another thing I'd really like to be able to do with a Vagrant plugin is have multiple roles with the same name and figure out how to address them. That's a question that we have not solved yet, but I'm interested in that too if anyone is doing anything similar. Okay, well, thank you guys very much. It was good talking to you.